Good evening, Physics B2 class. My name is Jake Steele,
Kevin Feldman,
Garrett Hawkins,
and we are here to present to you the wonderful physics of the sport of golf.
From the tee to the green, physics is seen throughout the game of golf. Today, we will focus on the physics concepts that are involved in a swing, a putt, a chip, and a drive.
First, we are going to analyze the 4 key elements of Tiger Woods' swing. At the back of his swing, Woods utilizes his flexibility to reach far back, extending his range of motion while keeping his rotating torso directly over his right leg. As he begins to swing, Woods builds up club head velocity by turning his torso quickly and pressing his right leg forward. Throughout his swing, Woods wastes little energy by maintaining his position above the ball. Woods drives through the ball using his hips, shoulders, and wrists to concentrate his force and create a very high initial ball speed. Within 2 feet of the tee, the ball is traveling at around 180 miles an hour, 20 miles an hour faster than the average tour pro. Woods allows the club head's momentum to extend his follow-through far around his back, completing a long and smooth club head rotation.
The first element of a swing is contact with the ball. When the ball is hit, it rolls up the club face due to the friction produced by the grooves on the club and flies off with a high speed above the horizontal. The momentum of the collision is conserved because of the high speed of the ball after the collision and the slowing down of the club head during the collision. The collision is not elastic, meaning that mechanical energy was lost during the collision when the ball flattened.
Concerning energy, the golfer rotates the club backward to a maximum height, thus increasing the potential energy of the club. Then the golfer exerts a force causing the club to accelerate as it rotates downward towards the ball. The work done by this rotational acceleration and the decrease of potential energy as the club moves down toward the ball equals the kinetic energy of the club just before the ball is hit. As the club hits the ball, part of the kinetic energy of the club is transferred to the ball. This kinetic energy produces the initial projectile velocity of the ball. The rest of the kinetic energy of the club causes the club to rotate upward to its maximum height after hitting the ball.
Acceleration is the motive force behind the power in a putt. To produce the most power, the club head should be speeding up as the ball is struck and not slowing down. To get good acceleration, the swing must have a very deliberate transition from the backswing to the forward swing and continue to speed up through the impact zone. Acceleration is increased by a golf ball's dimples, which augment the turbulence very close to the surface, bringing the high-speed airstream closer and increasing the pressure behind the ball.
Gravity is the single most important force that acts on how your ball rolls on an inclined surface. It is made up of 2 components. The first is the force that pulls everything towards the center of the earth. For example, on a flat green, it merely holds your ball against the surface, but doesn't move it. However, on a slope, there is a side hill component of gravity that works to move your ball down the slope. This is the component that you need to consider when putting. This is because as your ball slows down, gravity will increasingly affect its direction.
Forward momentum takes place when your putter makes contact with the ball. The amount of forward momentum is usually determined by the length of your backstroke. Motion occurs whenever the ball moves, either as a result of gravity or a combination of gravity and forward momentum. Your ball will stop moving when friction finally is greater than both of the forces of gravity and forward momentum combined.
Friction is the resistance an object encounters in moving over another object. It is the force that opposes motion. For example, when you put your ball on a flat and level green, it will roll until the energy imparted by your stroke is overcome by friction.
Drag and lift depends on 3 variables: speed of ball through the air, the rate of spin on the ball, and surface texture of the ball. Drag on the ball increases with speed through the air and spinning rate. Lift increases with rate of spin at a given airspeed and vice versa.
When considering the chip, the type of terrain the shot is played off will influence how the ball will travel. If you are on sand, Your swing must be altered in order to give the ball the height it needs to get out of the bunker. The swing must be shorter and more controlled as opposed to a shot taken on grass. The sand between the club and ball provides cushioning by absorbing some of the energy. Therefore, the distance of the shot will be determined by how far behind the ball the club head hits the sand. According to Newton's third law, forces act in pairs, equal in size but opposite in direction. So, during this collision, there will be an interaction of forces produced by the club and ball, and that impulse will determine the resulting speed of the golf ball, causing a change in momentum. This transfer of momentum from the club to the ball can be expressed by the law of conservation of momentum. In other words, total impact before the impact is equal to the total momentum after the impact.
There are three main physics concepts that apply to driving: double pendulum effect, torque, and centripetal force. A pendulum is a weight suspended from an anchor from which the weight can pivot or swing freely under the influence of gravity. A double pendulum consists of one pendulum tacked on to the end of another. The upper pendulum swings from a fixed pivot point, and a lower pendulum swings from the end of the upper one. In golf, the equivalent components are the shoulders, acting as the fixed pivot, arms and hands, the upper pendulum, and the club shaft and club head, the lower pendulum. As the wrists uncock near the bottom of the swing, the club head and the hands are moving in different directions, which means the club pulls against the hands and slows them down. This means, in turn, that the kinetic energy in the shoulders and arms is transferred to the club.
Torque, which is force times distance, is the turning force that changes the rate of rotation in an object. Golfers rotate their shoulders during backswing and twist their hips as they bring the club down to strike the ball in order to apply torque to the club. The more turning force, the faster and more powerful the drive will be, and the more force the drive will generate. The more you increase the radius of rotation of the backswing turn, the more you increase the torque generated in the turn. Likewise, the stronger the golf muscle, the greater the total force available for the swing.
The final concept is centripetal force, or the force that makes an object move in a curved motion. Golfers create this force by anchoring their bodies and pulling their wrists inward, while the golf club swings outward and through the second pendulum. As you are farther away from the center, you are getting more speed. The bigger the circle, the less centripetal force is needed to continue rotating the club so that it can move faster and therefore it move farther.
When the club comes in contact with the ball, it becomes a projectile motion because the ball travels a horizontal direction and continues moving due to its inertia, or the resistance of any physical object to any change in its state of motion, including changes to its speed and direction. Momentum and impulse are related because impulse is the change in momentum. In order to get the ball to move faster and further, the impulse and momentum of the swing must be of great values.
As seen through this informative video, there are many physics concepts that make golf the intricate and complex sport it is. It is important to master and understand the role that physics plays in order to perform well. Taking advantage of momentum, calculating the correct force needed to overcome friction, and applying Newton's third law to chipping will greatly improve your game.